All right. Just dimensional analysis is basically the. Oh, you can't see that because my projector is not on. That'll help. You need your notes up. Oh, while you're getting your notes, I might as well get a calculator out too. So dimensional analysis allows us to take seemingly unrelated units or measurements, and through the magic of mathematics, we are going to be able to relate them, okay? And we use a lot of conversion factors, okay? This right here, this 1 inch is equal to 2.54 centimeters. That's a very common conversion factor. So let's say we want to go from meters to inches. One's metric, meters. The answer we want is not. So we have to utilize that conversion factor, as I call like the stepping stone or the bridge that joins the two relatively unrelated units here, okay? So throughout the course of today and over the next couple of days when we do more practice, you're going to be seeing a variety of situations to where we're going to use a variety of different conversion factors. So how do we go about solving this? The first time, or whenever you do a dimensional analysis or conversion problem, you always list the given first. And the given's going to be the number of the unit that are given to you, hence the name, that you are going to start off with and then work your way towards converting them. Okay? So, in this really generic kind of setup, you have your given unit, multiply it by the conversion factor. Your desired unit, if you're just doing a one-factor conversion, it's going to go up top, and your given unit is going to go on bottom. By doing that, we can then cancel out the given units and end up with our desired units. Very generic, very straightforward. So really the best practice for getting dimensional analysis kind of down pat is to literally practice. So I'm going to give you a variety of questions today that we're going to work through, okay? We're going to start off by looking at a single factor conversion. We're going to work our way towards a multi-factor conversion. And then lastly, we're going to look at something, what happens when we're dealing with volume and we need to utilize dimensional analysis when we're talking about volume, okay? So I'm going to go down here. So let's look at, oh, just kidding. I thought that there was another thing here. Let's start off with an example, shall we? So we want to go from 8 meters to inches. When I do my dimensional analysis, and you might soon find a way that works best for you, but I really, for the most part, will do it every step. As you get more comfortable with this, especially metric prefixes and those conversions, you might find a way to maybe not include one of the steps because you're able to kind of modify another. And that is perfectly fine. So you will soon find a way that works best for you. I personally like to list everything out because I like to see it all strung out, but also I like to show you exactly how we got there, okay? So our given was 8 meters. Can anyone tell me how many significant figures there are in 8 in that number? It rhymes with something that has leaves and made of wood. 3. Yes, there are 3. 1, 2, 3. Going back to section 5 that had the video, there are 3 significant figures here. That's because of the all-powerful decimal, okay? If that decimal wasn't there, let's say if it was 800, then it would be 1, okay? But almighty decimal is going to allow those to be significant values. So we keep that in mind because when we finalize our answer is going to be reflective of how many sig figs our given has. Okay? So, moving along here, we need to go from meter to centimeter, and then eventually we're going to go from centimeter to inch. So, let's start off with that first one here. Pretend that's not even there. The conversion factor between meter and centimeter is that there are 100 centimeters in 1 meter. So, you just put their equivalents up here. 100 centimeter is equal to 1 meter. It also sets up a division problem. Okay? So you take your 8, multiply it by 100. The meters cancel. And you can divide by 1 if you want to. I think you already figured that out. So you take that answer. So 800, right? You'll then, because 800 centimeters. Okay, we're in centimeters right now in this step. So 800 centimeters, so take that and multiply it by the conversion factor for centimeters and inches. Okay? Again, our desired unit, what we want in our answer, needs to go up top. So we put 1 inch over there, and as we saw on the previous slide, 1 inch is equal to 2.54 centimeters. So you put the 2.54 centimeters on bottom. That allows the centimeters to cancel off there, leaving inches as our desired unit. We take 800, which we got from here, divided by 2.54, and we get 315 inches. Now, looking at the answer there, how many sig figs does that answer have? 3. That's 3. So it matches the number of sig figs that our given has. Okay? Let's look at some examples here. So, if a woman has a mass of 115 pounds, what is her mass in grams? Now, it says use relationships between units given on the back inside cover of the text. And if you look there, you'll see a whole table, at least you should see a whole table of conversions there. Okay? But typically, I tend to give you the conversions, especially ones that are not necessarily used as often. Okay, a lot of times, though, you're going to see your conversions using metric prefixes. So, again, looking at how we solve this, your given is 115 pounds. Okay? According to the back of the book, there are 453.6 grams in a pound. Okay? So, that's my conversion factor. My unit that I need in my answer goes on top. And so we take 115 pounds and multiply it by 453.6 grams. How many sig figs does 115 have? 3. Very good. So when you multiply 115 by 453.6, you're going to get a much larger number than 3 sig figs. That's where a good pal scientific notation comes in. Okay? So you can use scientific notation in all sorts of situations. So by utilizing scientific notation, we now have 5.22 times 10 to the 4th grams. Well, how many sig figs does 5.22 have? 3. And that's your answer. One step. Okay? So let's do one together. Here, I'll read it up here. By using a conversion factor from the back inside cover, determine the length in kilometers of a 500.0 mile automobile race. So, first off, let's get out of here. Let's go into here. Okay. Drew myself. So, I'm trying to get... Stop it. There we go. So, what do we write first? The given. And what is our given in this situation? 500.0. Very good. 500.0. And it is in miles. Excuse me. Now, can everybody see that? Okay. Now, before we go any further, how many sig figs does this one have? 4. Very good. 1, 2, 3, almighty decimal, 4. All right, so then we're going to multiply. Did anybody Anybody have their book on? Well, okay, so this should be in the back inside cover of your book. You don't have to get it out now. It's fine. But we need to have kilometers, right? So our desired unit needs to go on top. So I'm going to put 1 kilometer on here because I'm going by the conversion factors of the back of the book. All right. So in 1 kilometer, there is 0.62137 miles. Okay. Now, looking at what I've got set up so far, do I need to do any other converting, or have I arrived at what I need? I've arrived at what I need. And by setting it up this way, my units of miles can cross-cancel. So if you have your calculator out, I would like you to calculate this. And remember to put your answer in the same number of sig figs as you're given. Yes?
804.7 kilometers.
Very good. Yay, the label comes out. Yay. Love it. Because we don't know if we have 804.7 kilometers or 804.7 bananas. Very good. Anybody not get that? Easy peasy right off the start, right? Well, let's ramp it up a notch. Let's ramp it up. Hello, yes.
What page number is the conversion chart in the back of the book?
It should be like, as soon as you open the inside cover, it should be like right there. So yeah, on the very back. So on the very back of the book, just as you open the very back cover, it should be right there. And some of the newer books, it may not be there, it may have been rebound, but I believe it's not on the cover itself. It's on the page next to it. So it's there. All right. Oop, I need to get back in here. All right. So that was 1 conversion factor. Okay. So we move on to what happens if we have 2 units that we need converted. So looking at here, it says the average speed of nitrogen, we're in sample exercise 1.10. The average speed of nitrogen molecule in air at 25 degrees Celsius is 515 meters per second. Convert this speed to miles per hour. Okay, so we got meters per second. We need to go from that to miles per hour. So we've got 2 things that we need to focus on. So as you see, it gets a little busier. But don't let it scare you, because you don't have to do 2 at a time. Concentrate on 1 unit and converting that, and then move on to the next. And so as you see here, again, always start off with your given. 515 meters per second. 3 sig figs, that's how many sig figs we should have in our answer. So when you have a 2 or more factor conversion, I always encourage the students to start off converting the top unit. So the top unit, we need to go from meters to miles. Okay? Well, we've already seen that a kilometer and a mile have a relationship. They have a conversion factor. Okay? So what they do here is they convert meters to kilometers first. Okay? And so they go meters to kilometers, and using that conversion factor, okay, 1 kilometer over 10 to the 3rd meters. That means there are 1,000 meters in 1 kilometer. And by setting it up this way, it allows for the meters to cancel out. So now we're at kilometers. Okay? So, but we still need to get kilometers to miles. And you're going to notice that they have used a different conversion factor. In the back of your book, you'll notice that between units, there's usually going to be at least 2 different conversions available. Okay, the one we first used in the practice, okay, whereas 1 mile, or there are 0.62137 miles in 1 kilometer. You could also say that in 1 mile there's 1.6093 kilometers. It all works out the same. Okay, you just have to be careful on what values you use and where you put them. So, my unit of miles is now in our conversion factor. Okay, and they can't see me. Oops, they can't see the board anyway. So now our kilometers can cancel out, and so we've got the miles unit in the right spot. That's what's important when dealing with multi-factor conversions. Okay, is making sure the units that you are converting to are placed in the correct spot for your answer. So now that I've gotten to the point where I have converted to miles, I then shift my concentration to seconds. I now have to convert seconds to hour. Well, that's where the second part of this comes into play. So you've already set up the first part. We're going to kind of just leave that alone for now until we go to finally calculate it. Okay. Now we have to concentrate on converting from seconds to hours. Well, we know that there are 60 seconds in a minute. And you notice where I put seconds here. Put seconds on top so I can cross cancel all the way back at the beginning. Okay. And then I also know to get from minutes to hours that there are 60 minutes in 1 hour. So minutes can cancel, and now I'm at hours. But look where hours is. Is hours in the right location for our final answer? Yeah, because we're going to miles per hour. Okay. And so once I've got all this set up to where I've got meters to miles, seconds to hours, I can then do my calculation. And I highly recommend when you do a calculation like this, when it's this long and this involved, you do it one at a time. What I mean by that is do 515 times 1 divided by 1,000. Hit equal. And just keep building on that. You know what I'm saying? But also another piece of advice is check your calculators. Do you have parentheses on your calculators? Use them the same way as you see them on here, okay? Always use parentheses in these things, because when you start getting into situations like the 1 kilometer over 10 to the third, the parentheses kind of change up the processes of the calculator. So by using the parentheses, you're going to actually make the calculator calculate it correctly, okay? It's interesting how it works, but it does, okay? So let's do one together. Eventually, there we go. A car travels 28 miles per gallon of gasoline. How many kilometers per liter will it go? Well, let's get back into it. Okay. So what is the first thing I'm going to write? The given. And what is the given in this situation? Mm-hmm. We're on the practice. 28 miles per gallon. Excellent. All right. So we are going to focus on miles first so that we can get to kilometers. Once we've gotten to kilometers, we will then transition to go from gallons to liters. Okay, so that's our game plan. Coming up with a game plan when you get into kind of these multi-factor ones is a good idea to practice. What do I need to go first? How do I get there? And then from once I get there, how do I get to the second one? Okay, So let's focus on miles first. So we need to have kilometers. I'm going back to our conversion that we used before. 1 kilometer goes on top. Then again, the conversion factor between kilometers and miles is 0.62137 miles. Okay? There's more. One of those is a yardstick.
Oh, okay.
So, have I converted? Am I in a good spot for converting my distance? Yes. So, I'm going to transition. I'm now going to focus my attention on gallons and converting that to liters. Well, whenever you do use your book, you're going to see that, well, first of all, where do I need my liters unit? In the denominator. Good. So that means my gallon unit's going to go on top because that way I can cross multiply. Okay. In 1 gallon, there are 3.7854 liters. Okay. So I've got that. Are we happy there? We good? So I'm going to go ahead and cross out my gallons there. So go ahead and calculate that, and keep in mind, going back to the given, reporting your answer in the same number of sig figs that your given has. 2. Very good. So I want to go ahead and give you a moment to calculate that. Yes, ma'am.
Do you multiply the 2 denominators first and then divide by 28?
There's a couple of different ways you can do that.
So I'm getting like a decimal. And then...
So what I recommend doing is taking 28, and again, I do this step by step, Larry. So when I say multiply by 1, that's just keeping me on track, okay? So take 28 divided by 0.62137, hit equal. Got that? So then you know how you can hit second and then ANS. So you hit your second answer button, and that should bring up your previous, or it should say ANS there, and then divide it by 3.7854. You should get something around 12.
Yeah.
11.9.
Yeah, I would say even if you don't divide,
Yeah. So 11.9, which is too many sig figs, so 12. And then our label's going to be kilometers per liter. So you can break these down into single factor conversions. They're just going to be a little longer than your typical single factor conversions. Okay? Questions? All right. This next one, I think it's going to be best. Well, if I can ever get this straight, I think it's going to be best if we discuss what's going on and then actually do the practice problem, because I think it's easier to see and do than it is to just read off of there for this particular one. Stop. Okay. So this last one, or last one for the chapter, is when we're converting volume units. So here it says, I'm just going to read, this question. We're not going to work on this question right now because I want to do one together. But I want to point something out. Earth's oceans contain approximately 1.36 times 10 to the 9th cubic kilometers of water. Calculate the volume in liters. What's different about that value than what we've seen thus far? The cubic. Okay. So there are some things that we have to remember and do to solve volume unit conversions. Okay. So like I said, I'm just going to hop. Well, if we have time, we're going to come back and talk about that question. But I want to go to the practice one, do it together, and explain as we go, and then, come back if we can. So our practice question is, if the volume of an object is reported as 5.0 cubic feet, what is the volume in cubic meters? Okay. So I just can't seem to get it right. So again, write the given. And today is not the only day you're going to hear me say that. I'm going to say it so often, you're going to wish I didn't. Okay. So we need to go from essentially just really, really simplifying it, feet to meters, okay? But we're going from cubic feet to cubic meters. So we have to figure out what is the best step. How do we go about converting from feet to meters? Well, we know that there are how many feet in a yard? Again, rhymes with the leafy, woody thing. 3. There are 3 feet in a yard, okay? And if you look in the back of your book, which you don't have to right now, but if you were to do that, you would see that there is a conversion between yards and meter. So we know that there's feet in meter or feet in yard, and we also have a conversion factor between yard and meter. So I'm going to use yard as my kind of go-between, my bridge to connect these two. So, and just so you know, 1 meter is equal to 1.0936 yards. Okay, we're going to know that. Okay, so we're going to use yards as our go-between. Okay, so where does yard need to go in my setup? Where does yard need to go in this step? Top, very good. 1 yard, and there are 3 feet in a yard. But there's a problem. Right off the bat, there's a problem. Nothing you did. Exactly. We cannot cancel feet cubed and feet because they are not the same unit. So how do we go about that? Trickery. We have to cube the entire conversion factor. So there's a reason why I erased down here, because I'm going to be kind of rewriting it as we go, because you'll see in just a second. So what is 1 yard cubed? It's just 1 cubic yard, basically now, right? But remember that for the denominator here, we have to cube the 3 as well as the unit. So what is 3 cubed? 27. And so then it is going to be cubic feet. Okay, now I'm going to go back up here. Again, we can go from meters to yards to meters. Okay, and that conversion factor that I had on here, 1.0936 yards. But again, everything's going to be cubed after this step. So I'm going to have to cube everything there again. You can't see that. There we go. So now, again, cubing this factor, first of all, we see that these can cancel, right? We get 1 meters cubed. And so what is our yard value cubed? Well, let's keep that. Okay, 1.307 cubic yards. Okay, and looky here. Cubic yards cancel. What are we left with? Yeah, meters cubed, cubic meters, however you want to say it. So now what I need you to do is take 5.0 divided by 27, get an answer, take that answer divided by 1.307. And reporting your answer in 2 sig figs, because there are 2 in the given. 0.14 meters cubed. Excellent. Excellent. So you have to be very careful. You've got to be aware that if you are presented with a unit that is either squared or cubed, okay, you will have to make adjustments accordingly, okay? And you can't just cube or square a denominator or a numerator. You have to do it to the entire conversion factor, okay? Questions on this? Feeling okay with it? Good. Again, we're going to do some more practice Tuesday. I might send a few extra. I might do a couple extra things just on Monday just to keep us fresh, just for you to look out for. And other than that, that's a wrap for chapter 1. Chapter 1, not chapter 6, because that would put us, that would put us in the second semester. Kind of wish it was, but hey. All right. So, again, if you have any questions over this, what I recommend you doing is continue working on your problem set, because the quiz for sections 5 and 6 is going to be Wednesday. Okay? That's when the problem set will be due. Yeah.
That's the second part of that.
Yes. Yep.
Do on Wednesday?
Due on Wednesday.
So do you want us to scan them in?
No. Oh, sorry. The quiz is Wednesday. I would like you to have your problem set done Wednesday for the quiz, but you'll turn them in Thursday. Okay? I'm going to go ahead and stop.